We're going to talk today about redundancy. This is a matter that's showing up more and more on RFPs that we're seeing out. High availability, the need for no single point of failure. We're going to talk about that today. Okay, redundancy. In order to achieve high availability, you can go with a third party, VMware, high availability, fault tolerance. Those are tools that exist off the shelf and you can use those. Those have been tested with Omni, so that's okay. Or alternatively, you can go with our proprietary Watchdog redundancy. And today we're going to talk about that. Why would you go the Watchdog as opposed to going with the VMware or some other third party? Well, I think probably the most important one is the third bullet, is how it's affordable, right? I believe it's significantly less expensive than going for a third party high availability solution. But also it's more tailored for the Omni. So it's monitoring indicators of the Omni server. For example, if you have a thread that locks the server for some reason, and it'll monitor for that. If you have a high CPU, or if you have some queue that's exceeding the of inbound messages, meaning we have distress signs from the server. So the Watchdog will try to attempt to restart the server again and again. If it fails, it'll transfer over to the passive. So this is a more tailored redundancy, high availability scheme for Omni rather than something generic. They'll say, okay, run, go, no go. If it's running, fine. If it's not running, transfer. When you are working with the Watchdog, then you can manually transfer if you want. Let's say you have maintenance that you need to perform on the server. You need to transfer over the server to another machine so that you can clean it up or provide backup or update operating system or whatever you need to do on the primary machine or the active machine. Then you can transfer back and forth as needed, right? And of course, if you have a catastrophic crash on the primary server, then it will fail over to the backup. You can manually transfer, or of course it'll fail over in the event of a crash, right? So let's have a look now at the tool. It's called the Watchdog. Now, most of us are familiar with the Eiris Watchdog, but we run it in the default mode, which is the Eiris Watchdog-Lite. So if I look at my desktop here, and I've got two shortcuts, the Watchdog Redundancy and the Watchdog-Lite. Now, the Watchdog-Lite, if I look at the command to run it, it's just the Eiris Redundancy Watchdog. But if I look at the Watchdog Redundancy, then I add the /redundancy as the flag to tell it to run in redundant mode. So if I double click on the plain Watchdog-Lite, then I'm going to get this well-known user interface. Still, it's a very important tool because we can use it to monitor the server. So you can launch it as a service. It'll keep an eye on Eiris, make sure, or Omni, make sure it's running correctly. And if it is not, it'll restart it, etc. It monitors for all sorts of indicators and timeouts, etc. So that's great, and it has a log. So that's what we've been doing, and you can run as a service or run as a desktop app. Now, if you run the redundancy option, right, then as you can see here, the user interface looks a little different. And here we say create a new instance, because the whole concept of redundancy is you have an instance, and the instance moves from machine to machine, an instance of the Omni server or the Eiris server. So we're going to demo that in a moment, but let's see what happens. If you're running the Eiris-Lite, as I said, it supervises, it can restart it, and it can run scripts. You can create batch files or shell scripts that run before and after the server is launched, and it's got a detailed log. If you're running it in redundancy, then the active and the passive communicate with each other and they transfer control. So here I have a little animation, put this together for you today. And so I've got the active machine here running a Watchdog. The Watchdog, I start the instance and it's running the Omni server and it keeps monitoring the Omni server. On the passive side, I launch the passive server and it connects to the active Watchdog. I launch the passive Watchdog and it connects, the two Watchdogs talk to each other. In the meantime, I don't have Omni running, the Omni server. I don't have the Omni server running on the passive machine. However, when I run the passive Watchdog, it launches what's called the dummy client. The dummy client connects as a client, just like EV2, connects to the active server and updates the database on the passive machine. So it's updating its own client-side database, and it's slightly different than EV2 because EV2, what happens is when it starts up, it retrieves all of the files from the server, creates the database locally, and then it doesn't update that database while it's running, okay, until you restart the EV2. In the case of the dummy client, it's updating it every couple of seconds, so it's keeping it current and so that we have a synchronized database on the passive side, right? Then I have let's say I have a crash on the active. It goes away, right? The redundancy watchdog copies that copy of the database over to the server, and it starts up the server, right? Now I have the passive machine is turned into an active machine. Now, when I transfer manually, the old active is going to turn into a passive and connect backwards, and I'm going to demonstrate that for you right now. Okay, so if I open up my remote desktop, so this window here, right, is my remote desktop on my server machine, next room here, and this is the Watchdog running on my laptop from which I am working. Right now, this server is running. I started the server. It's got an instance, and I have an instance ID. This is kind of like a random ID number, but I can define a fixed number if I'm starting it up as a service so that I know that when the passive starts up, it'll connect to that instance. But let's do it manually for now, just to understand a little better. So I'm going to select a NIC, a network interface card, through which I'm going to communicate or search for an instance. And I'm going to click Search Network Instances. Now, when I do that, the passive Watchdog is now searching, and it discovered, got a little bug here that is showing it twice, but that's probably because I've got a docking station here. But I've got two, it doesn't matter, I'll pick one of them. And I'm going to select Join the Instance. So what's going to happen here, you see on the server, on the active side, it's detected that it's got a passive A that's starting up. I can have multiple passive machines, by the way, passive Bs that sit in the background. And as you can see here, I've got this little indicator, this little user interface, which shows that the dummy client is running. Okay, so passive A is connected, everybody's happy. The passive machine is sitting there. I don't have a server running on my laptop. I just have the Watchdog, right? And it is communicating with the Watchdog on the active machine, and all's fine. Now I can request take control. Of course, if I kill the server, meaning I power down the server, let's say, then the passive machine will detect that it lost communication with the active, and it will take control. It will start up the server. I can alternatively do a manual transfer, and that's what I'm going to do right now. I'm going to click request take control. And what's happened is, as you can see on the remote machine, it's shutting down the server, and on the passive machine, it shut down the dummy client. And in a moment, you'll see it's starting up the server. So Eiris server is started. By the way, I have the alert notifier running, and the alert notifier is jumping between the two of them. What I neglected to show you is here, I've got EV2. EV2 is probably not responding because it's in the transfer mode. EV2, here you can see EV2 has lost communication. EV2 is connected to the remote machine. We've got the server is now running happily on the backup machine. It's got the remote, and you can see that the EV2 has now connected, automatically switched over to the other machine. And if I also give you a glance at my display panel, you can see it's showing it's unreachable at the moment. But if we wait, we'll see that the display panel will also, there it goes. So the display panel also automatically switched over to the new machine. If I generate an alarm alert, I could see the alert notifier also is now reacting to alerts generated from the new active, which is my laptop. So our clients more or less moved over. What won't move over is if you have a browser, if you're running the web client in the browser, anytime you do something, it's going to show that it's not logged in because you have a manual login. I believe that EV3 will transfer automatically if you're running EV3. If you're using a browser, then that would need to be logged in again. But then again, the user is going to control that, so that's okay. But the display panel automatically switches over, alert notifier switches over, EV2 automatically switches over. And that is the demo of the manual transfer from the server. Now, if I shut down gracefully the server on the active, then the passive won't take control because the watchdog knows that this was an intentional shutdown, right? So let's go back to our presentation here. Again, the passive watchdog monitors the active watchdog, the dummy client synchronizes the Omni database, and the dummy client database is transferred. Excuse me. Okay, so the assumption is that the network link is stable. So that's critical. In other words, if somebody comes, if you have a link between the active server and the passive and you cut the line between them, then there will be no way for the system to know that the other machine is still running. So what's going to happen is you're going to have duplicate instances of Omni. And that's unpredictable what can happen, meaning the two servers are battling over the same, let's say, readers and devices. So that's not a good thing. So that link between those two machines must be reliable, meaning that if the passive detects a failure in communication with the active, that means that the active server has crashed, not that the network has gone down. The Redundancy Watchdog can support multiple NICs, so therefore you can have redundant NICs, but and you can have a redundant network and redundant switches, but all I'm saying is that you have that link between those two servers has to be reliable. If that goes down, the concept fails, okay? The various monitors that the watchdog is looking for, high CPU, locks, etc. Back queues for the inbound messages if it exceeds a certain number, meaning Eiris is failing to handle all the inbound load traffic. The next thing is, how do I manage to get those web clients to switch from one machine to the other? Okay, EV2's got its own mechanism because it uses the engine, but the web clients are connecting via an IP address. So how do I move the IP address from one machine to another? So in actuality, I'm using what we call a portable IP. That's the name that we coined. Each NIC has their own base address. So in the case of my server over there, it's 192.168.1.200. And in the case of my laptop, it's 1.227. But when the Omni Watchdog, when the Eiris Watchdog launches the server, before it launches the server, it runs a script file. So if I look at my Redundancy Watchdog, I go to settings, I go to events. I can define what's called, now it's running, so I can't edit it, but I'm able to define script files or batch files on Windows and say, okay, when I start up Eiris, when I transfer Eiris, when I performing some type of a critical event transition, then run this batch file. And you could use that for backing up. You can use that for whatever you want to do in that batch file. In our case, what we're doing in the batch file is we're running this command with a netsh interface add or a netsh interface delete, where I'm adding a second IP address to a particular network interface card or NIC, right? So all my devices, whether it be the Omni Go, whether it be the display panel, whether it be a web client, is looking at the portable IP, the 150. So if I click now, active turns into, so now the 150 transfers over to the new active machine, and everything else connects accordingly. You cannot use the portable IP if you're using DHCP, right? This command of the interface IPv4 add will not work if you're using DHCP. Now, there's another mechanism that we added in order to shorten the transition time, because everybody asks, okay, what is your availability time? Are you 99.9? Are you 5 nines, 6 nines, 4 nines? How many nines are you in terms of uptime? Well, that's a function of, okay, let's say I assume that I have a physical crash of the machine once a year, once a month, whatever, right? How long will that transfer take from the backup machine, from the active to the passive? So generally, it can be pretty quick. Let's say 30 seconds of what we had here. But you can, if you have a very large site and you need to initialize an entire network. So what you would want to do is you would want to skip a lot of the initialization of those readers. And you can do that. You can set up in the server INI to skip the initialization parameters. And then have the devices such as the Elpas readers, the Elpas ELC, whatever, the IP devices out there, not use the base IP address of those NICs, but use the portable IP. And then what happens is Omni doesn't need to initialize all of the network devices during the startup. But in order for Omni to tell the ELCs to use this alternate address, you have to set that up in the INI file. So you do, okay, this is my base address, and this is for this NIC, which is the 1200 NIC, I want to use this IP address. So every time it sends a message of set params on those ELCs, it's going to tell the ELC, now don't report back to the 1200, report back to the 1150. Yeah, so the next thing is if I want to launch Omni automatically, right? I want to launch with the server starts up, I want to launch as a service preferably. So the Omni Watchdog provides you with the ability to register it as a service. And then what you do is you give it a keyed in, like a hard-coded instance ID. And you give it a time to search for that instance before starting up its own instance. So what happens is you've got two machines, right? So this machine powers up and it's going to start searching for that instance on the network for X number of seconds, in this case, 30 seconds. If it finds another instance, it will connect to it as a passive. If it fails to find that instance, it will start up its own instance with that ID. Then the second machine starts up. It's going to start up, going to search for that instance using that hard-coded instance ID. It's going to find it, it's going to connect to it, and it's going to remain as a passive. So that's how things automatically work out. Where is the challenge here? With Windows 10, with Windows 10, there's a problem that once the service starts, we no longer have access to what's called the session 0 of Windows, or the 0 session, which is the desktop for the system user, the user that launches all of the services. And therefore, you can't get in and start messing around with the Watchdog if it's run as a service, and you can't start initiating or shutting down instances if you want to. You have to go ahead and kill the sessions in the task manager. So if you want to initiate the Watchdog, but have access to that user interface currently, because we're trying to fix that, but that's until that happens. If you want to run it automatically, you can put a batch file in the startup folder of Windows, and you can simply run the Watchdog command where you use /redundancy /instance and the instance ID and the search time. And that way you'd have essentially the same behavior as you would, and then of course you would need the system to automatically log into that user in Windows in order to run that startup. So what you're doing is you're basically, it's like a service, but it's starting up as a desktop application. Then you'll have in the system tray the Watchdog icon that you'd be able to get to, and or on the bottom of the screen in the taskbar, you'd be able to get to the Watchdog and make any changes you want to and edit that. As I said, we are working on a solution for that. We have to separate out the user interface as a separate process in order to run as a user process, and that's being done. So I believe that's it. Thanks a lot, everybody.
Thank you, David.
Thanks.
You're welcome.
Thanks, David.